one. Boom.
All right. So solving quadratics by factoring. So we need to quickly review how you want to go about factoring any polynomial. We're going to start with quadratics. But the first thing that we need to talk about are my rules of factoring. And in year-long Algebra 2, we spend about, a month doing this. And so you've got experience with this. The first thing you want to look for is the greatest common factor, or GCF. So the biggest number that will go into a set of numbers, or the most number of variables that both terms have, or something like that. So greatest common factor is what we want to go with first. Okay, hang on just a second. Let me mute that. All right. Okay, now, after you've gotten the greatest common factor out, you want to count the terms. And based on how many terms there are in the polynomial that you're dealing with, or problem that you're trying to solve, is going to tell you what method you can use to solve, or what method you could use to factor that polynomial. If there are two terms, we're going to look for what would be called a difference of squares, and we'll see some of these today. Squares. Or there might be what's called a sum or difference of cubes. We won't see this today. This is later on. Okay, we'll get to some of that cubic things. We're dealing with quadratics, so the biggest exponent we're going to deal with today is x squared. Cubes is going to be x to the third power. So that we won't touch that today. Okay, but if there are two terms, those are the options that can happen, and we'll talk about how that works as we go through here. If there are three terms, this is the most common thing we'll do today. We have this thing called the X method for factoring. We'll review over that. If you had me for Algebra 1, then this is the way we did that in Algebra 1. If you had Coach Mack, that's the way he did that. I'm not sure about Coach McLean-McGee. I think they did, I don't know if they called it the X method or not, but they did the same thing. Okay, it's just the layout. My wife does the exact same style of factoring as I do. She just doesn't call it the X method. She uses a table and does it that way. So that's just later, meaning we're not going to do that today. We'll get to that later on. All right, if there are four terms, and this does come up today a little bit in that how we would factor a trinomial. Sometimes we make it into a four-termed polynomial to factor it. We're going to use a method called grouping. Okay, and we'll review all of these as we go today. All right, so we're going to solve quadratics by factoring today, and then later on we'll do quadratic formula, and then we'll do a thing called completing the square. We'll get all these methods for solving quadratics. Factoring is the most I don't know if it's the most useful method or not, but it is a very common method for solving them, and it's going to be useful when we get to bigger polynomials that have like x to the fourth power, x to the fifth power, stuff like that. So being able to factor is an important skill. Okay, so we're going to kind of review as we go here how you can do that. So there are only two rules of factoring. One of them is greatest common factor first. Every problem you look at, you're going to say, is there a greatest common factor in this problem? If there is, take care of it, and we'll see how to take care of that in just a minute. And then if you've done that, the next thing to do is look at how many terms are there, 2, 3, or 4. If there's more than that, then it just extends it a little bit further. We usually, in Algebra 2, we're probably not going to get anything bigger than a 4-termed polynomial that we're asked to factor. We'll be asked to solve something bigger than that, but factoring may not be the skill that we use to do that. Okay, so those are the two rules of factoring that I go with here. Okay, so let's look at some factoring. Before we get into solving, we want to factor the polynomials. Okay, so we're going to kind of review all the different ways of factoring as we go through this, and then we'll get into the solving, which is just the application of the factoring that we do. All right, the first example, we want to factor this. Let's say it's 3x squared plus 12x. Okay. So the first thing we want to look for, if we're going to factor that, is the greatest common factor. So we look at that and say, okay, is there anything in common between a 3 and a 12? 3 goes into both of them. What else is in common between these two terms? An x. Both of them have an x. This one has how many x's? This one has, so they have how many in common? 1 in common. Like this guy's got 2, that guy's got 1. You can only pair up one of them. So there's one x that's going to come out with that 3 as the greatest common factor. And then you're going to have parentheses. What times 3x gives me 3x squared? X. Yeah, 1x or x. What times 3x gives me the 12x? 4. And you don't need the x because it's already out here. That's the factored form for that polynomial. So that's using the greatest common factor is what we're doing there. It's just using the greatest. You can get into the other rule because the greatest common factor was the only thing that existed on this one.
Why are we breaking it apart? Is that our answer?
That's what we're doing right now. We're going to use these broken apart pieces to solve with here in just a little while. Okay, so we're practicing factoring so that we can use those factors to solve. Okay. Example B. Let's say we had maybe x squared minus 9x plus 20. I look at that. How many, or first thing I want to look for in every problem is the greatest common factor. Is there anything in common amongst all 3 terms? No. So I go to the next rule. It says count the terms. How many terms are there? 3. This is where we're going to use that X method. It's what I call the X method. It may not be how you learned how to factor. It's not how I learned how to factor in school either. I learned by guess and check.
I just remember hearing about factoring, but I don't remember.
It's not bad. If you know your multiplication tables, it's really easy. If you don't know them, learn them. So I make a big X. And then, did he? Okay, good. So whatever's in front of x squared, you multiply it times the number on the end. I did this too. 1 times 20 is 20. That number goes in the top. It's not just the number down here. Okay, don't fall into that trap. Whatever's in front of the first term times that number is what goes up top. And then whatever number's in the middle goes in the bottom.
So the other one would have been 36.
No. It only works when there's 3 terms. You don't do this if there's 2 terms. Now, yes, the number in the middle goes in the bottom.
I remember this.
As far as the -9, no.
I never learned it.
All right. Now, the next thing we want to try to think here is what multiplies to be 20 and adds to be -9. 5 times 4 is 20. 5 plus 4 is 9. What could I do to them to make it a -9? Make it -5 and -4. Now, some of you this is really, you remember doing this in Algebra 1, you know that there's a shortcut at this step. If you don't remember that, you can do this. So what I'm doing is I'm replacing that middle term with the 2 numbers from the x. And then that makes this trinomial into a 4-term polynomial, which I can group. What we're going to see is that the shortcut that happens when there's nothing in front of x squared, but this method works even if there's some number there, okay? So we're going to group first 2 together. What does x squared and -5x have in common? They both got an x. What's it leave in the parentheses? X minus 5. Then I look at the second 2. What do they have in common? 4. Yeah, 4 goes into itself, 4 goes in 20. Now, the thing I've got to look at is the sign that's on that right there. If that's a minus sign, then I need to pull out a negative, whatever the common factor is. So a -4 is what I'm pulling out to the front. And that's where a lot of people have some problems, is when they forget to pull that negative sign. The reason I need to pull that negative sign is because I need these parentheses here to match this one here. So -4 times x gets me -4x. Negative 4 times negative 5 gets me positive 20. So that's why I have to pull that minus sign. Okay? And then my factors, yeah, x minus 4, the stuff that's in front, and then the matching parenthesis. Notice they're right here. Whoops, got the wrong color. I don't think black's going to highlight it too well. X minus 4 is that. And then x minus 5 is that guy. Okay, whatever's in front is going to be one factor. The matching parentheses is the other factor. It really doesn't matter what order you put those in. If you put x minus 5 in the front, that's okay. Okay. Let's look at another one. Let's say we had 5x squared minus 17x plus 6. And we want to factor that. Well, it's not that bad. It's the same thing.
What about 6x? Let's change it 6 to 6x.
No. Because then it's not the same rule.
No.
Is there a GCF?
No.
Not amongst everybody, okay? So the next thing to do, how many terms are there? 3. So I'm going to use that X method again. So what goes on the top? 30. 5 times 6 is 30. Negative 17 goes in the bottom.
Negative 15 times negative 2.
That's good. Negative 15. 30 came from whatever's in front of x squared times the number on the end. 5 times 6 is 30. And then 17, negative 17 comes from the middle piece. That's always going to be the bottom. Negative 15 times negative 2 is positive 30. Negative 15 plus negative 2 is negative 17. We know that's the right pair. Next step is to go, and it doesn't matter if you put a minus 2x or a minus 15x right there. I'm going to put the minus 15x because I know 5 and 15 have something in common. So that makes it a little easier for me. Group. What do these two have in common? 5 and 15. 5 and an x, leaving x minus 3. How many do they have in common? They have 1 in common. So if I pull 1 out, if I take 1 away from 2, I get 1 left. Okay, so the square's technically still there. What do these two have in common? A 2, but I need to pull out a negative 2. That's right, because that minus sign that's there. Whatever the sign is right here, that's what's going to be right there. If it's a minus, that's going to be minus. If that's a plus, that's going to be a plus. And then we'll have x minus 3. It's 2 times x is 2x. 2 times 3 is 6. That's why that's that. And then our factors are now evident. 5x minus 2 and x minus 3. The factored form. Factor that one. Excuse me. So, what number goes on top? 12. What number goes on the bottom? What multiplies V12 as V8? 2 and 6 or 6 and 2, whichever way you want to do that. Now, here's the glorious part of the ones that have a 1 in front of x squared or nothing written there. You can go straight to your factors. X plus 6, x plus 2. It works. If you did the grouping work that we did right here and on the previous example, it ends up being that. Whatever numbers are here on the sides. If there's nothing in front of x squared, you can go there. That's a positive 6, that's a positive 2, so they're pluses. If one of them's a negative, it's a minus sign in there. Okay? So that shortcut is very helpful. Okay? Example E. Let's say we had n squared plus 2n minus 63. Okay. Is there a GCF? No. So I'm going to go ahead and go to the X method because there's 3 terms. What number's on top? Negative 63. And a positive 2 on the bottom. I just, no, what?
Just hold on one second. I'm so right. I got it. It's 7 and 9. So it's negative 9 and 7.
All right, 9 and 7 I agree with. Okay, what'd you say?
Negative 7 and positive.
Negative 7, positive 9. Because negative 7 plus 9 is positive 2. And then we know if it's going to multiply to be a negative, they have to be opposite signs. The biggest one will always be the sign of what's in the bottom.
Yeah, so this is gonna be x plus 7, x minus, or x plus 9, 9,
Yeah,
plus 9, and 9.
good job. Yeah, that's right. Because there's nothing in front of the squared, you go straight to that factors on that. All right, let's look at this one. 12x squared minus 28x minus 24.
Does it matter what order that you write?
No, if you wrote in minus 7 and n plus 9, it's the same. It doesn't matter. Okay?
There's a
4 goes into everything at the biggest one.
But I thought you had to have an X on everything for the greatest common multiple.
No, it doesn't have to have, like, when you look at 12, 28, and 24, 4 goes into all of them. That's a common factor. It doesn't necessarily have to have an X to be a common factor. But 4, it does go into all of them. So I'm going to factor out a 4. That'd leave me 3x squared minus 7x minus 6. Right?
Yeah, sure.
What times 4 gives me 12? What times 4 gives me 28? And 24. Now, can I factor what's in parentheses any further? Sometimes you can, sometimes you can't. Let's check to see if we can. That'd be negative 18 up top, negative 7 on the bottom. 3 times negative 6. Front of x squared times the number on the end is the negative 18. The number in the middle is always going to be on the bottom.
So really, you probably get the same answer. It's just simpler to do it like that.
Well, if you factored it like with the x method at the beginning, you know, what's 12 times 24? It's a really, really big number. And then, and your factors will have greatest common factors inside of them, and that you would have to get out at the end. So you get, if you'll get the GCF out at the beginning, it makes the numbers a lot smaller, a lot easier to work with. Because I can work with 18 a lot better than I can. What's 12 times 24? That'd be 144 times 2, 288.
There's not anything that'll go into it.
Is it negative 2 and 9? Negative 9 and 2. They know their multiplication table. 9 times 2 is 18. I know that's 7 apart, so I just got to get the signs right. And then, can I do the shortcut on this one? No, because that 3 in front of the x squared. So I got to go 3x squared minus 9x plus 2x minus 6. It does not matter which order you put those two things in there.
It don't matter.
So it doesn't matter which way you put those in there. Your factoring will look a little different than ours, but your final result should be the same. Okay? So I'm putting brackets here to say that 4 is still out in the front. And then I'm grouping that stuff. 3x squared minus 9x, they have what in common? 3x, leaving x minus 3. The next pair has 2x minus 3. So your final factored form, it's got the 4 you pulled out at the very beginning, a 3x plus 2, and an x minus 3. Oh, it's 4 steps. Yeah, the 3x plus 2 is the stuff in the front. That's that guy. The matching parenthesis is the second factor. And that 4 is from the very beginning.
Is this just review? Or is this what we're doing?
This is what we're doing, but it should be review. All right.
I never learned this stuff. Like, I remember going over it, but I never got it.
I remember copying.
We'll catch it now.
Yeah, right.
All right. So let's look at this problem. X squared minus 9. Okay. Now, is there a GCF? No. How many terms? 2. So that tells us to look at our rules, say that if there are 2 terms, it could possibly be a difference of squares. Could be a sum or difference of cubes, but we know that's not going to happen today. Okay, because it's squares, right? Square x is squared there, so it's a squares. So what we want to do is rewrite that problem as a difference of squares. That means difference in math means subtraction problem. Squares means to the second power. So what squared gives me x squared? What squared gives me 9? If I can rewrite it like that, then it's a difference of squares. And it'll factor really easily and quickly. X goes in the front, 3 goes in the back, 1's plus, 1's a minus. That is the way, that's a kind of almost a memorized pattern. It's a shortcut to that. Really is what it is. Is there a greatest common factor to that one? No. How many terms? 2 with a minus sign in the middle. So that makes me think difference of squares. So I'm going to try to factor it as a difference of squares. Something squared minus something squared. What squared gets me 4x squared? 2x, good. 25 is coming from 5 squared. Our factors are then 2x plus 5, 2x minus 5. Differences of squares. They're shorter. They're easier. Let's look at this one. 49 x squared plus 42x plus 9. Is there a GCF?
No.
Dang. It'd been nice if there was, because 49 in the front means when I do my x method,
49 times 9.
yeah, which is what number?
I beg it.
40 times 9 be 360 plus 81, 441. And then it's got to add to be 42. Now, here's kind of a hint on this one, and ones like these. What do we know about the number 49? How many times? 7. So it's 7 squared. What do we know about the number 9?
3 squared.
It's 3 squared. So those are 2 square numbers. Okay? So anytime that happens and we're having to factor this thing, yeah, you think about squaring something. So I think, what's the square root of 441? Use your calculator, it's fine.
21.
21. Is 21 plus 21 42? Yes. We have 49x squared plus 21x plus 21x plus 9. Group. Oh, this is easy now. Should be. All right, so 49 and 21 have 7x in common, leaving 7x plus 3. 21 and 9 have positive 3 in common, leaving 7x plus 3. Our factors then, 7x plus 3, another 7x plus 3, or you could write that, yeah. Yeah, it's okay. That's real nice. What that's called, what this trinomial here, the trinomial meaning 3 terms, what that means is that's a perfect square trinomial because it squares to be the same factor twice. Those have special properties about them. Doesn't necessarily change how you do it, does it? I mean, we did it the same way, but it's just, kind of neat. Some neat things happen with those as we go further and further in this stuff. All right, let's look at one more of these. Let's say we have negative 16 n squared plus 12n. You go so stuck doing the x method, we forget how to do the other stuff. Say that again.
4 would be the greatest common denominator.
Factoring me? Greatest common factor? Yeah.
Greatest common.
4 goes into 16, goes into 12. What else do they have in common? An n. They both have an n. Now here's what I want to, 4 is the right number, but because the one in front of n squared is negative, when you factor that 4 out, factor the negative out with it. That's going to help you when we go to do the solving. Okay? So just remember, if there's a negative in the front, factor the negative out with your greatest common factor. Okay? If you'll remember that, that'll help you when we do the solving part. So negative 4n, that would mean we have 4n minus 3. Good. Change the sign. Because negative, we're pulling out a negative, it's going to change that sign. And then, does the parentheses factor any further? No, it's just 4n minus 3. It's just pretty plain, so got that. All right. Let's look at another one here. One at factor. I'll just make one up. All right, let's look at this one. Say we have x squared minus 8x plus 13.
Well, 13 is prime.
Which one? It's not both. It's prime, that's true. 13 is prime. So that means when you do the x method, 13 and negative 8, only numbers that can multiply to be 13 are 13 and 1. And they're, if I made them both negative, there's no way those both add up to be negative 8, right? So this cannot be factored. No. Doesn't mean there's no solution. Just means it can't be factored. Another word for that would be prime. a polynomial can be called prime. If if it can't be factors, like 13 can't be broken down into smaller parts, this polynomial can't be broken down into smaller parts using factoring. You need, well, no, that's how we decide that it's prime, because we couldn't get anything that multiplied to be 13 and add to be -8. We couldn't get anything to do that. So if it cannot be factored, I'll take that answer, or prime. Your book tends to use the words cannot be factored. Prime is maybe, maybe a more college level, I guess. My college textbook uses prime, so that's why I use prime. Let's look at the next step in this stuff, and that's the solving. Factoring is the key. That's how we want to solve today. Okay, so if you're going to solve one, you're going to use the method of factoring. And in order to factor, you've got to have this thing called the zero product property. What the zero product property says, if two or more factors multiply to be 0, then at least one of the factors is 0. It could be all. Okay. That last thing is my addition to that. Could be all of them that are 0. Because 0 times 0 times 0 is 0 still, right? So if we can get something written as factors, i.e. using our factoring skills, then we can solve it by realizing, hey, if these two things are factors, they multiply together to get 0, then I must have one of them that it's at least one of these is 0. We're going to take the worst case scenario that all of them are 0. That's what we're going to do to solve these. Okay, so to solve a quadratic by factoring, you want to get the problem equal to 0 first. Okay. Factor. That's the steps. Get it equal to 0. Sometimes it will already be there. Then factor it. Once you get the factoring done, set each factor equal to 0 and solve. All right. So let's take a problem, a trinomial that we've been working with here, and let's work it out. I don't know what letter, JKL. Let's say we had x squared minus x is equal to 42. That's our first problem. Is it equal to 0? It is?
No.
Looks like it's equal to 42. So I need to get it equal to 0. So how? Subtract the 42. If I subtract 42, that'll get it equal to 0 on that side. And then on the left side, we want to write that in descending order. So we start with x squared, then the x, and then the number. X squared minus x minus 42. Then,
So that's not messing with A.
that's not messing with x because they're not like terms.
That's what I thought.
Yeah, because the 42 doesn't go with. If there are like terms, Jordan, you're going to put them together. Okay, and we'll look at one that does that in just a little bit. Okay. All right. Next thing to do is factor it. So I want to multiply to be negative 42, add to be negative 1. Negative 7, positive 6. Can I use my shortcut on this one? Yes. Why can I use that shortcut again? Nothing in front of x squared, so it's 1 in front of that. So I can go x minus 7, x plus 6 is equal to 0. The next step is set each factor equal to 0. X minus 7 equals 0. X plus 6 is equal to 0. Solve each of them for x. X equals 7. Negative 6. Notice the opposite sign of what you found in your x. That should be the case. If there's a 1 in front of x squared, that's what should happen. Two. Let's do this one. We have 3x squared plus 5x minus 8 is equal to negative 5x.
Couldn't you, well, if you add it, you had to add 5x, so would it be 10x and all?
Yes, that's absolutely correct. Good job. That's going to get like terms together when you try to get 0 on the other side. So add 5x. There's my 0. And then you're right, 3x squared plus 10x minus 8. That's what I'm trying to solve. It's 3x squared plus 10x minus 8. So I want to try to factor that. What number goes up top? 3 times negative 8 is negative 24. 12, negative 2. Yeah. And then, can I do my shortcut on this one? No. Don't automatically jump to that shortcut. Almost every time I teach this, folks just want to go x minus 2 and x plus, or x minus 2 and x plus 12 and solve those, and that's wrong every time. So don't jump into that pitfall. Plus 12x minus 2x minus 8, and then group. Those have 3x in common, leaving you x plus 4 minus 2. Yeah, the first two together and then the second two together. That's what I mean by group. That's right. Yeah, just 2 at a time. Because that's, what do these two have? That's their GCF. 3 goes into 12 and itself, so that's the 3. They have 1x in common, so that's where the 3x up front comes from. Because that's the GCF of the first two terms. And then negative 2 is the GCF of these two terms. Now it's getting out in front there. And then we have 3x minus 2, x plus 4. What do you do with each of those factors? Set them equal to 0, solve. So x would be, what, 2/3 and negative 4. By just doing the regular equation solve stuff from Algebra 1 or 7th grade, or 6th grade. They actually may do problems like that in 5th grade now. That part, the red part, not all this stuff, obviously not, but the red part they do solve. Okay. There's really not much else to this, guys. I mean, you get better at it as we do more of it. You'll get better at it as you do more. If you're working at it, you'll get better at it. You just gotta be creative with your numbers, know your multiplication tables, and then say, okay, well, how far apart are those numbers? And then that helps you get the sign right. Kiana, did you have a question, or are you just fixing your hair? Okay. Stretching that hanging down. All right. Okay, this is what I want us to do today and tomorrow as well. So we're going to practice factoring. This is going to be your chance to get better at factoring so that as we move forward, you'll be able to do this as we go. So I want you to look at page 255 3 through 37 odd. And then those should all be shortcuts because they're in the first section. That the way your book splits it up, there's a 1 in front of x squared in that first section on all of them. If there's not a 1 there, there's probably a GCF that would put a 1 there. Okay, so look at that on that first section. Section 4, 4 is the ones where it's not a 1 in front, so that's on page 263. Let's look at 3 through 39. Okay, so you've got about 30 minutes left in class today, and you're going to have time tomorrow to work on this as well. And then Wednesday, you've got the day off. But if you're struggling with factoring, you need to practice it some more on your day off, maybe, hopefully, so that you're ready to go on after that. So we're going to spend time solving by factoring. We'll do square roots next. Then we'll do quadratic formula, complete the square, all that fun stuff in here. And then we'll have a test over solving, and then we'll do the graphing part separate. Yeah, if you want to work together today, yeah, absolutely. Get better at factoring. That's the plan, is factor and get more practice at it, okay?